Hello everyone, this is Skiwi from Ice Pops, and today we'll be making a realistic airplane in Unity. Well, the physics system that we're going to use is Ivan Pensionerov's system, and he's also another YouTuber. I'll link him down below. I'll also have a link to the GitHub where we have all our code and the assets used. And keep in mind that although his physics system does cover most things needed for an airplane, today we'll be making specific things such as the flaps, the brakes, and a way to control the thrust. Alright, let's start. So first we're gonna go to the Git repository for aircraft physics, and we can just clone the repository. So click here on the code button and click the paste button, and now you can go into your file system and in wherever you want. I have a folder called Unity Projects. You can just create a new folder right here, and you can name it whatever you want. And since I already have one named airplane physics, I'll just call it physics for now. Inside physics, you can right click, go to git bash, in git bash write git init. This will create a new repository in this folder, and then you can go git clone and paste the code right here, paste the little URL. Now it'll clone all the information from the online GitHub repository to your local repository, and as you can see right here, the folder is right here. Yep, it's done. So now when I go into this folder, there'll be the assets, packages, and project settings. And now you can go into the Unity Hub and just add a new one. Here you go to Unity Projects, find the folder that you put it in. So for me, I put it in physics, and I'll click on plane and I'll click select folder. And now it'll be here. Since it's not updated to a particular version and I don't have the version that he has, I can just click here and change it to the version that I have. And then I will just click here and it'll open up the project. Alright, so before we add anything, we're just gonna go through some of the things that he already has and check out what each of them do. So first I'll give a brief introduction on his physics system, but of course you should go watch his video to get a in-depth overview of what his system does. So basically his system will calculate the individual forces that are acting on each surface. So for example, the wings can be a surface, and you also have the rudder or the elevators. Those are all surfaces. And then he combines all of them together and puts forces on the rigid body component in order to make the plane act fairly realistically. So it uses mainly 3 scripts. If we go in here, example, and we go to scripts, it has airplane controller. And when we double click on it, it'll open up in Visual Studio or whatever text editor you have. So here I have airplane controller. This is the highest level of the 3 main scripts. We'll talk about this a bit later. Now if you go back to aircraft physics, you can go to core and find scripts. Here the main 2 are aerosurface and aircraft physics. So go ahead and open both of those up. Here we have the main 3, and aerosurface is the lowest level. So aerosurface is what calculates the physics for each individual surface, and this script will be on every aerosurface on the airplane. Like you'll have one for the wings, one for the tail, one for the rudder, etc. And it's very low level. It does calculations on the forces. You shouldn't directly interact with this class much. Mostly you can interact using aircraft physics and airplane controller in order to control the angles of the aero surfaces, and there's not that much of a need to change this class directly. So I'll talk about some of the main functions. First of all, the most important one for sure is set flap angle. So one of the fields that this class has is a flap angle, and basically if I show you in Unity, this is what the flaps look like. Here, when we go in the scene view, this is the plane that he has set it up for us. And as you can see under aircraft, you have the aerodynamics, and under aerodynamics, he has all these objects, and they're basically just empty objects with an arrow script on them. And because he has a gizmo script, which you don't really have to worry about, it shows you the size of each of the arrow surfaces. So right here, as you can see, the blue part is the part that you can't control, and it's basically just stationary, and the yellow part is the control surface. So that's what set flap angle does. Set flap angle will allow you to set the angle of the yellow part, so the control surface. And next we have calculate forces. So what calculate forces does is you input a couple aerodynamic coefficients, and after that it will output the force and torque. So this means the lift force as well as the drag force and the torque force, which is like the rotational forces. And finally, there's calculate coefficients. This is mostly for drag and lift. So this is called by calculate forces, and this is just specific to drag and lift. Now we can go on to aircraft physics. This is a slightly higher level script, and basically what it does is it has a list of aerodynamic surfaces, and this would be all the surfaces. So if we go back to his plane, he has the aircraft physics script over here on the plane, and underneath in the aerodynamic surfaces he has 7 of them, and that's just all of these surfaces. And he also has the control surfaces, so he only has 5 here. That's because the control surfaces are only the stuff that has these flaps on them. So as you can see, he has 2 body ones. He has body 1 and 2, and they have no flaps on them because you're not supposed to be able to control it, and they're not control surfaces. So they only exist over here on the aerodynamic surfaces and not the control surfaces. So first we have set thrust. Set thrust is pretty simple. It just sets the thrust percent, and the thrust percent is used to add a force to the rigid body to go forward. There's also set control surface angles. This is really important. This is how all of this information is inputted into arrow surface, and that's how you control all the each of the control surfaces. So you can do pitch, roll, and yaw, which are basically the 3 movements that the plane usually does. And then after that, there's the calculate aerodynamic forces. So this will basically add up all of the aerodynamic forces and calculate exactly what it needs to input to the rigid body. And all of these ones under it are basically used by the calculate aerodynamic forces function. So you don't really need to worry about it. And now we'll move on to the airplane controller, which is the script that you'll be doing the most changes and add-ons to, because it's the highest level script, and this is exactly where it takes input. It processes the input and sends it to aircraft physics, basically. So over here, you can see that he has already just set the thrust to 1. This set thrust just sets the thrust percent, and the thrust percent is just put into aircraft physics. And over here, we can go ahead and put all of this in update instead of fixed update, because it's just getting the user input, and these 2 functions are what's actually inputting the user input into aircraft physics, which is the physics, which should belong in fixed update. So that's all you need to know about the systems that he's already set up, and next we'll move on to how to add on to these systems and make a working plane. Alright, so now we're going to go in and add our first new feature, which is going to be a way to control the thrust. So right now, as you can see, the thrust is just set to 1 right off the bat. And if we go into Unity and you play the game, it immediately begins flying without any need for user input, which of course is pretty nice, but I think it would be better if you could add and actually control how much thrust you're putting in. So in order to do that, let's look at the code for airplane controller. So airplane controller has roll control sensitivity, pitch control sensitivity, and yaw control sensitivity. And these sensitivities are basically in order to control how much the user is actually putting in and how much is being passed over to aircraft physics in the set control surface angles. So right here, as you can see, pitch, roll, and yaw is just the sensitivities times the get axis, input.get axis. This means that if we want to do thrust, we'll also have to do a thrust control sensitivity. So we can just put that right over here and just name it thrust control sensitivity. And you can default this to a little bit lower than 0.2 because for thrust we'll be adjusting the percentage of thrust, not actually how much newtons of thrust we're putting into the rigid body. So like this will probably be a lot better. And as you can see, there's already a float thrust percentage, so that's all we have to change. But instead of defaulting it to 1, we're just going to default it to 0. So for thrust, I thought about this, and I thought that thrust is best controlled with the space key. So we can just do an if statement. And just setting the thrust like this is pretty solid because it just adds on a certain amount of thrust when you're pressing the space key. So that's pretty nice. So now if we go into the game, now as you can see, even though the propeller is spinning, it's controlled by a different script, so it's going to be spinning. But we're not actually adding any thrust, and when I press spacebar, it's going to go forward. Of course, there's no way to decrease the thrust, so there is no way to land yet, and that's what we're going to be adding next. So in order to decrease thrust, we'll just have to have a way to basically reverse the thrust, so reverse the thrust control sensitivity. And I thought that whenever you press the shift key, it'll just shift into reverse mode. So we're gonna make the reverse function right now, and we'll do shift, left shift or right shift, they both work. And here you can just set the thrust control sensitivity to that. So basically every time you press left shift, it'll just flip the thrust control sensitivity. And just like that, in the game we'll be able to slow down. So as you can see, now we could speed up, and when I press shift once, and then now we can slow down again. And you can see over here that we are actually slowing down, because as you can, oh shoot, there's a problem. I messed up. So instead of doing get key, you have to say get key down, because for get key, it returns true for every single frame that is pressed. So it was switching back and forth between negative and positive super fast, and that's why it wasn't working. For get key down, it only returns true on the key that you press it down. So every time you press it, it'll just flip it once. So that'll work a lot better for us. And without even playing the game, I can see that it's working. I'm not pressing space right now, but the thrust control sensitivity is set to 0.2. I mean, of course, 0.01 would be better. And now when we press shift, it switches to negative. And when I press space now, nothing happens because it can't go below 0. Now if I press shift again and then space, it'll go forward, and shift again and space back in order to decrease the thrust. And there's not a lot of drag, and there's no brakes yet, so of course it's still going pretty fast, but as you can see, it's definitely not taking off. As you saw when we were trying to land, there were not actually brakes, so the friction was really low because there's just sphere colliders with 0 friction on the ground, and it just kept sliding. So right now we're just going to add some brakes, and there's a super easy way to add brakes because as you can see in the game, the person who created this physics engine didn't actually use wheels because Unity wheels are pretty glitchy. So that's a pretty smart way to just use sphere colliders and make them really slippery. Basically this just has 0 friction. Yeah, 0 friction. And so what we can do is just increase the friction on slippery when we hit a certain key. Like for example, when we hit the key B, we'll just increase the friction. And for this, I decided that we can put it in aircraft physics because it has more to do with physics. So down here, just go to the bottom, but before this new class, we can just create a new function. Actually above here. And you can just call it public, so public void break, and all it does is it takes a boolean is breaking, and if is breaking is true, it'll set the friction higher. If is breaking is false, it'll set the friction back to 0, and it finds all the wheels, which are the only sphere colliders in the scene, and it'll just add it to the dynamic friction. So now we need to call this from somewhere, and of course the best place to do this is from airplane controller. So in airplane controller, just like everything else here, you can just copy and paste this really fast. And we also use get key down instead of get key, because if you click the B button and it's longer than 1 frame, then get key won't work. So we can just hit B right here. And right now, do we have a reference? Yes, we do. So we already have a reference to aircraft physics. And right now we can just, I think it's called physics. No, it's called aircraft physics. Aircraft physics.break. And actually we can put this function down here because it's in fix update along with everything else. And then up here we'll create a boolean break. And in this, we'll just set break to true and false. So break equals whatever the opposite of whatever it is now. And in here, we'll just input break. So up here, we can just make break default to false, which I think it already does, but I'm not exactly sure. And this should work. Now we'll see. So with brakes on right now, yeah, I'm going forward a lot slower. And I'm gonna take off brakes and I'm gonna try to slow down with the system that we made last time. Yeah, as you can see, right as the front wheels touched, we face planted because the front wheels had too much friction, and I couldn't touch the back wheel first because I suck at flying. So yeah, we have the brakes working, and of course you can play around with any of these numbers over here, maybe more friction, less friction, and play around with the material. Like you don't have to make this minimum, average works. So far we have added thrust and brakes, and that's all really nice, but there's one super important feature that we're missing, and that's actually flaps. So flaps are on the edge of the wings, and they're not actually on the edge of the wings, they're actually towards the middle of the wings. And if we zoom in on the plane that we have, which is right here, you can see that right now on the wings, when we go into aerodynamics, we just have a left wing and a right wing, but actually flaps and ailerons can be separated. So right now we're going to implement flaps. First, let's just duplicate the wings. And now we have 2 wings. Let's name this one flap left and the other one flap right. So now we've got flaps and wings, except they're in the same position. So what you can do is right over here in the configuration, you can change these variables. What the configuration is, it's a scriptable object that holds information about the wings. So you don't have to worry about any of these except for the chord, flap fraction, and aspect ratio. The chord is how wide it is, and the aspect ratio is how long it is compared to how wide it is. And the flap fraction is how much, like what is the percentage of the flaps compared to the entire surface. So for the wings, this we can rename it to ailerons. And I'm just gonna move these up because they're all kind of like in the same group. And over here, we can change this wing config. So let's go with something maybe a little less, like 1.1. That looks about good. And move it to the side a little, just like that. Alright, that looks pretty good. And now of course we could just move the other one the same distance away. So that's all. But for the flaps, we're gonna have a slightly different configuration for the flaps. So let's just go into surface configs, and we can right click, create aerodynamic surface config, and we can call this flap. There we go. So now we have this, all of the variables are pretty much set up correctly. We can make the chord the same as the wing, so the wing is 1.8, and the flaps will also be 1.8, and the aspect ratio can be something like 1.1. And 0.2 for the flap ratio, just the same as the wing. That's pretty good. So for both of the flaps, instead of having the wing config here, we'll just change it to the flaps. And as you can see, the wing and the flaps they are slightly different. And actually we'll just make this 1, not 1.1. There we go. So the flaps will be slightly shorter than the wings. And now we move the flaps over and set up the wings as well, so that the flaps and the wings are basically right next to each other. There we go. And this is 1.36. Alright, so perfect. So now we've positioned our flaps and our wings just like this, and they're looking pretty good. So basically we split up the wing before into 2 parts, which both have their individual components. And in order to actually be able to control the flaps, we'll have to add it to the aircraft physics. So instead of having 7, we'll have 9. And these bottom 2 are just duplicates of that one, so you can just drag in flap left and flap right. And since it's also a control surface, well, 5 plus 2 is 7. So there we go. And in these last 2, we'll put flap there, just the same as before. Now you'll notice that down here there is a type, and right now there's just pitch, yaw, and roll, which the flaps don't really go into any of those types. So we'll go into aircraft physics, scroll all the way down, and you can see control surface. So that's the object that that this system has, and as you can see, control surface type, those are the 3 types. So we could just add a 4th type right here, flap, and we head back to Unity real fast and change these both to flap. And there we go. Alright, so now we have basically set up the main system over here in the Unity editor. We'll hop back over to the script. So in the script, right now, the most important thing that we have to change is basically the set control surfaces. So right now there's pitch, roll, and yaw, but obviously you want to add flaps so that you are able to control them as well. So I'll just say float flap. And as you can see, it uses a switch statement, pitch, roll, or yaw. You just copy this over real fast. Dot flap, I believe that's what I named it. Yes, that's correct. Control surface dot set flap angle, and we'll just set this to flap. There we go. And now this will pass it over to arrow surface, which we can worry about a little later. Now, there's going to be a slight problem, I believe. Yes, there is. So right here, this function right here called calculate center of lift, it passes it over to the gizmo script, and that's what draws these nice blue squares around where the surfaces are, and that's really nice. But basically it needs the new things. So because it uses set control surface angles, it needs to have a flap. So we can just add also here float flap. So basically right now we're just going in and correcting all the places that need this new flap thing. And over here as you can see, we now need another one called flaps. So we can go settings dot display flap control, and display flap control doesn't exist yet, so we'll have to create this in settings. You can just hop over to settings just like this, if it'll let me click it, and here it is. Yeah. So in the aircraft Gizmos, there's the settings, and right now the settings won't work because as you can see, it only has the 3 of display pitch, display roll, and display yaw, and it's very easy to just copy and paste this, and of course change this to display roll control. Oops, sorry, not roll control, display flap control. And now this will basically fix everything up, I believe. Yes, it does. And back in arrow surface, let's see if Unity gives any errors. There's an error right now, but I think, yeah, here it is. So we need also a roll, but this is for later with the airplane controller. And also over here, aircraft gizmos. It seems fine now, which we fixed. Okay, so finally we need to set up the input in the airplane controller. So in the airplane controller, I like to use control for flaps. So control is just putting down the flaps, and the flaps aren't really controlled like the other control surfaces. Like roll and pitch is usually using a joystick, and the yaw is usually using foot pedals, but flaps are like kind of like this little tab that you can pull down. So with flaps, I just like using control, and there's just four settings, like 25%, 50%, 75%, and of course 100%. And it's really easy to set this up. You can just copy and paste this right over here. Of course, get key down, because you don't want it so that when you hold the key down, it just instantly goes to max flaps. And control, yeah, left control is fine. And up here, just add another one. These are all of the control surface settings, so just add another one called flaps. And we also need another control sensitivity to control how much the flaps are turned every time. I believe 0.15 works very well here. Change this to flap. There we go. Now with the flaps, all you have to do is just flap equals and then flap equals there we go. Flap plus equals flap control sensitivity, so that'll add it every time. And you also need a special clamp, because the normal clamp, when you clamp it in aero surface, when you set the flap angle, they'll clamp it for you. So it's this, but they have positive and negative, and this means that it can go up, whatever this comes out to, and also down. But for the flaps, you just want it to be able to go down. So we're going to cap it like this, and this is exactly the clamp that we're going to use in aircraft controller. So this is a special clamp. And right here, there we go. So this will make sure that the flap is actually correct, and it's clamped between 0 and whatever this comes out to. And now set control surfaces, super easy, just implement it, flaps. And let's check out if it works. I'm not sure if there will still be errors. It looks like there's no more errors, but there may be runtime errors. So as you can see right now, there's no flaps. 1, 2, 3, 4. Looks pretty solid. Alright, but now, right now, there's no way to bring the flaps back up. So let's see if we can change that. Actually, let's change this to 2, because I believe that was the setting that made it so that it would be 4 times exactly when you got to 100% flaps. So 1, 2, 3, 4. Yep, that seems about right. Okay, so in order to make the flaps go back up, I think we can just use the same system that we used for the thrust. And you can just do this right here, and flap control sensitivity. Yep, that's perfect. And right here, it'll just set the flap control sensitivity also to -1. And we go back. So right now we'll just bring the flaps down, 1, 2, 3, 4. And press shift to bring the flaps back up. Oh, that's nice. And when we press shift again, now we can bring the flaps back down and up, just like that. Alright, well, that's it for flaps. And now we'll just do a little bit of flying. Hey, what's up guys? This is post-production me, and I just realized that there's a couple things we can fix. So if we look at the game right now, and we hit play, yeah. So the propeller is already spinning, even though there is no thrust right now. And when we press the space bar and we start moving forward, there's a lot of thrust, but it's still spinning at the same rate that it was spinning before. So this is not. That means that the propeller is just not synced up with the thrust percent that we just implemented earlier. So what we can do now is go to Visuals, Super Spitfire, and find the propeller object. On it has a rotator script of a speed of 1500. Just set this to 0 because we'll be setting it in the script instead. So if we take a look at the rotator script, here it is. It has a public float speed, and this speed is used to rotate the object around a axis, which is the y-axis. We don't need to change anything about this script, we just need to be able to change the speed from a different script. So that script will be the airplane controller. And inside airplane controller, all we have to do is add a new reference, and this reference will just be to a rotator. There we go. That's perfect. And in order to find it, we can just go propeller equals find object of type and rotator. Alright, so that's perfect. Now what do we do with the propeller? That's really simple. We just go into the spot where we take the input for thrust, and we can just set the propeller speed to thrust percent times something like 1500. So when the thrust percent is 1, so that's 100%, then it'll be max speed of 1500 RPMs. And when it's like 0.5, that's 50%, it'll be half of this, and so on. So that should work. Let's go back into Unity and see how it performs. Alright, perfect. So it's right now I just pressed the spacebar and it started spinning. And if I press shift and cut all the thrust, it immediately stops spinning, which of course is not so realistic because there's no rigid body on it, so it doesn't simulate physics. If you wanted to simulate physics, maybe you can play around with the rigid body, but I'm not going to today. So yeah, we have that fixed. A second part is the lift slope. If we take a look at aerodynamics and look at any of these surfaces, the lift slope is always going to be 6.28, and that's a calculated value from I believe it's the thin airfoil theory. And basically most surfaces will have this type of lift slope, and that just means based on the angle of attack, how much lift is it producing. And this is all well and good, but if we go into aero surface right here, we'll find that the actual lift that's being used is the corrected lift slope, and this is because the actual lift slope in real life is based on this lift slope constant and an aspect ratio. So as you can see, it just takes the config.lift slope and multiplies it by this equation that uses aspect ratio. But the problem with this is when we split the wing into two parts, the ailerons and the flaps, this means that the aspect ratio for each one is much smaller than it was before. The original one, I believe, was 2.1. So what we can do to fix this is basically we can just grab an if statement and say that if the game object has a tag of wing, so we'll just tag the ailerons and the flaps with wing, then instead of basing it off of config.aspect ratio, we'll just base it off of this variable right here, float aspect ratio 2.1, and the corrected lift slope will be the lift slope times this aspect ratio, which was the original wing's aspect ratio, instead of its actual aspect ratio, and this will increase the lift by a lot. So what we need to do to make this work in game is just go in and add a tag to each of these. Add a new tag, name it wing, and aileron, and both of the flaps, tag them as wing. And I think this should work. Let's see. Alright, no more errors. Press space. Yes, it is far easier to take off now, and even when I'm not pressing the down button to pitch up, I'm still flying rather level, which is much better than before. So this is more accurate to how it was before, and this is more accurate to real life, and that's the final fix. So now we have a completely working plane. If you enjoyed the video, please like, comment, and sub, and I'll see you in the next video.